Hello YouTube, so today we're going to be talking about what is the difference for hunting and target shooting. So I'll open these up here and we'll take a look at them off the bat. You can see they are both 180 grain 7mm bullets. But however, something very striking we'll get to here in a second is that the optimal twist rate for these ones is 1 in 9 versus these ones are 1 in 8. But the ballistic coefficient on both are pretty dang close, if you ask me. I don't know how much of a tenth of a difference would equate to. Somebody could tell me that's a huge difference, but realistically they're nearly the same length and exactly the same weight and shape. So you can roughly see here they are extremely close to the same length. I apologize for the lighting. Same shape, same boat tail, same weight, same everything. Same tip even, they're both this teeny tiny hollow point tip. So, I mean, literally they are so close to the same that if I were to mix them up, the only way I would be able to tell which ones were which are with a set of calipers. So I'll show you here the difference in their length with the set of calipers right now. So you can see roughly here, these ones fall right around 1.525. So they'll fall right around here, and don't use this as a reference because my actual dial calipers are off. They don't have a wandering zero, but they are not completely accurate. They're not the best. They're not 100% true. So with that being said, this is a generalization. But normally, the target bullets, the very low drag target bullets, will fall right in between that 20 and the 30. So I did run these through about 4 from each box, and the hunting ones are all consistently shorter versus the target ones are all consistently longer, so it's not just a variation in the manufacturing. So here you can see that little tiny gap between the two, the hunting one being on the bottom. And as you can see here, here's the hunting one, and we're falling somewhere in the realm of 1.5. 6, 7, somewhere around there. Normally, for all the ones I've been measuring, they do not go over the 10 on the dial. So, with that being said, they are all consistently shorter / all consistently longer. So, we're going to, as best we can, split them open with a Dremel tool and see if maybe the core extends further on one or the other one, and just what makes the difference between the two of them, as far as I'm concerned, are nearly the exact same bullet. But clearly here we have, one says recommended for hunting, excellent target, but the very low drags for the target are recommended for target but not suitable for hunting. So we're going to see why that is. Why is one of these all of a sudden not suitable for hunting and one is, but they're nearly identically the same bullet? So here's our answer. As we can see here, the one on the left is the target bullet, and the one on the right is the hunting bullet. As you can see here, the lead core on the hunting bullet extends significantly further than that of the target bullet. And I apologize, this was not the easiest thing to do with a Dremel tool. It's a bit hard to tell, but the actual copper jacket on the target bullet is more pronounced and thicker than on the hunting bullet. I still don't quite understand why that would merit two completely different straights. I can kind of see why in theory you wouldn't want to hunt with it, but the difference between the amount of copper in the front and the lead core extension in the inside really doesn't jump out as very different to me. In fact, I would have thought the opposite as far as twist rate goes, that the one with the lead core extended further would need a tighter twist rate. Like I said, I could be getting a lot of this wrong. If you have any explanation as to why one is more suitable than the other, and I guess the only thing I could think of is maybe the one on the right would promote the jacket to open up more effectively. But if you have an answer to this or an answer to why it needs a faster twist rate, so I'd be very interested to hear why. Thanks.